Hello, Southern Hemisphere. Um, I wish I could be there today, but I had some travel chaos that came up, and then my laptop display died. So I am recording this at a university library in the United States on a laptop that I rarely use. I hope you'll bear with me. Um, as it says on these slides, I'm Nathan Willis, and we're talking about modern fun with old fonts today. Um, I actually have a secret title, which I like to do for most of my talks, um, which explains maybe a little more efficiently what's going on. This is to talk about pulling apart font files and figuring out what we can do to use them on a modern system. Because formats change and support goes away. Luckily, there's a long tradition of doing something useful despite those circumstances. You might wonder why this is something worth talking about. I came up with some reasons, and we'll talk about these in turn. People care about their old fonts, but the reasons are pretty distinct and may not all be the same and may not all have the same solution. So for one thing, they like the aesthetics. Like, this is a book called Arcade Game Typography by a guy that I happen to know, and it's one of the best-selling books about typography ever made. And people love working with these in designs because of the vibe and because they want to use that aesthetic in a new way. But it's not just arcade games. This is also popular with retro computing fonts. I, for one, still remember the early Macintosh fonts, Chicago. Those elicit a reaction when I use them. So this is something that people care about for that particular reason. I would also say, there's a distinct use case to be found when it's not the vibe, but it's a particular document. This is a Wired article about, I think, during the George W. Bush administration, trying to figure out if a document was as old as they said it was. So that's obviously high stakes. The stakes might be lower for most people, but they could still be important. You might need to know if that word appeared in the contract or on the invoice that you had from 10 years ago, or if it got cut off accidentally. And you're stuck without a really good answer if you have to reflow the text with a different font in a different application. So, there can be some real reasons that you need that to keep working on some particular day. Another thing is that people spend money on fonts, and nobody likes being told that the thing you bought is worthless now. We, I think, get that as FOSS community with stuff like ebooks and DRM. So this is on the same continuum with, hey, you have to buy your movie collection again. It makes people upset because they have something that worked and then it doesn't work anymore. And yeah, the right answer in theory might be for someone to just go buy or find the OpenType or TrueType version in a modern format of the same font. But if they have to buy it, that's a cost to them. And it's also easy to say that for one font, but I think maybe the bigger use case is when people bought something with 300 or 400 fonts in it, and having to rebuy all of that I think it's understandable why they'd be upset. So I think we should find a better way to give them an answer and a way out. Apart from those basic uses, I think there's some environments where modern fonts just aren't suitable, and this includes things like hardware that shows bitmaps, or hardware that shows bitmaps for a particular application. Aftermarket firmware, the old Linux console, for example. And there's documentation instances related to that. And then there's the whole issue of devices that are cutting or routing things, which is a big maker issue. For instance, these character displays, super common, there's 1,000 of them. They can only display bitmap fonts. So you might have one of these and learn that it doesn't have the accented letter that you need for your name. So how can we change the font on that? That's a valid question to ask. This is a project you may or may not have heard of called CHDK. CHDK is a replacement firmware for Canon cameras, the point and shoot variety. I've actually run it on this. It doesn't replace the original firmware. It just gives you new features. It's kind of a cool project in a lot of ways, but it has to use a character display to show its menus, so it needs some fonts for that. And then of course there's the question of, well, what do you do if you have one of these displays and you need to document what you did? This is an illustration from the Arduino forum. Obviously that 7-segment display thing, you don't want to have to draw everything by hand, and if you're writing a manual for CHDK, you would like to maybe have some fonts to give you that look that people are going to actually see. I didn't actually think of this one until I was making the slides, but I think it's worth considering. Then yeah, the cutting of things, that's sort of a different use case entirely, because when you talk about laser cutting and CNC machines and vinyl cutting even, they work on a path, and the path has a beginning and an end, and it is not a filled in letter like the way we fill in letters as we are rasterizing text for modern displays. And so this is laser cut. This totally different device, still uses the path. This is the National Park typeface, which is meant for using a plunge router on blocks of wood. So you have different needs in vinyl and in etching PCBs, for example, but they all kind of come back to the same thing where it has to be a single path, and that's not what a modern font is. And then finally, I have a secret ulterior motive I want to talk about, which is that I am wrapping up my PhD program in Reading, England in typography, and part of my research involved peeling back layers of font specification, which was valuable to do. You see people raging about old font formats being dropped, but I think if we get past the black box view of what's in the font, maybe we empower people to do a little more and not have such a negative experience, let's say. Now, for this next slide, if I was there in person, I would ask this and ask for a show of hands. What's inside a font file, but I'm gonna have to answer that myself since I'm recording. I'll just tell you the generic response. People will say letters, or more broadly characters, letters and numbers. In type design, they use the term glyph, which just means anything drawn, so it would include punctuation and all that. Other people will say a little more. They'll say things like the font names that you see in the menus, or they'll say kerning, which probably means more like the metrics for positioning things, but they know there's some other things in there. Well, this is a quasi-periodic informal chart that I made of all the stuff that could be in a contemporary font file. We're mostly going to care about the top half here. Those are the tables. The bottom half is other well-defined subtables and bits and chunks that could be in there. So where the strings are, what the names are, that kind of thing. These are kind of sorted by me. The first couple columns there are the real basic ones. You get to that fifth column, that's OpenType layout, which is features and things. Then after that is variable fonts and color font formats, for example. The black ones there in those two columns are Apple's advanced typography, which is not really documented and supported outside of Macs and iOS, I guess. The final two columns are sort of single application things, which are not really part of the official specification. The teal ones are open source. It's usually just sort of like the top one is TTF AutoHend, and the table that it writes into a font is just sort of what parameters were used. The blue ones are Microsoft. The gray ones at the top right corner are from SIL graphite fonts. EPAR, the orange one, I think was proposed and never implemented, and then the red ones at the bottom are specialist Adobe things. Well, that's a lot of stuff, right? Let's look at what's actually necessary, though. The gold line that you see here is what tables are required for something to be an OpenType font, and it's basically just that first column. The blue line is everything that's required to be a TrueType font, and you'll see those are mostly the same. And there's a ton of flexibility in all that other stuff. All that other stuff is optional. The sort of pinkish, I don't know, bracket on the side there just says SFNT, which just defines these format for all of these things. And I thought I should put that in there because that term will come back later. But this flexibility that we have is something we can exploit to make use of old font files. But I wanted to start with the takeaway that TrueType and OpenType are not mutually exclusive. They overlap a lot. They leave a lot out. You have a lot of choices you can make, and they're really just lists of requirements. I think we talk about them as if they are formats that are completely different, when in fact they share a lot. And a lot of the things they share are super common. The second takeaway is to realize that where the glyphs are is one of those choices. And there's 7 tables in that block that can have glyphs in them. The first few there you see are for vectors. So an Apple style TTF file would have a GLYF table. CFF, CFF2 are sort of the Adobe style Beziers. Then there's an SVG table for SVG fonts, which a whole thing created separately. The last 3 are all raster images. EBDT is grayscale bits. CBDT is color ones, and SBIX is kind of just a PNG. It's the emoji format that Apple came up with. So if we look back at those reasons that people had for caring about their old fonts, I would say some of these can be addressed at the end user level, by which I mean not asking the text handling stacks to perpetually support an infinite number of applications. But there's some choices that have to be made. Like the red X by old documents, I think what you really need there is probably a VM, right? Like there's too many other things in the application OS stack that have changed since 15 years ago for you to just say, oh, I'm going to alter the font and put this old font in, and then we'll look at the old contract. So a VM is the solution there, not really an updated font file. On some of these others, I think there are some choices. Like for aesthetic and creative projects, we can do a little conversion and make those usable in GIMP and Inkscape and applications like that. Obviously, documentation would fall under that. It turns out that the CNC and laser cutting, not too bad to support either. And there's some question marks on some of the others. Like if you have a font library, okay, we could convert a font, but is that really the best answer for you or not? Not necessarily an easy to answer question. So what I'm going to look at in this session are 3 specific technical cases, and they're listed here in order of decreasing complexity. Say as far as like what it takes or what we need to do, and in an unfortunate way, that's also like decreasing success rates for the average person. And don't worry, I am going to include a bunch of links at the end, so if any of these things speaks to you, just hang on, and I think we'll have some time for questions. I'm trying to talk really fast, but we'll see. The other thing that I wanted to mention before moving on, though, is that I can't stress enough that this is a hobby deep dive of mine. This is not something that I do all day, these conversion of things. I think I understand what needs to happen in some of these cases, but it might not all be great news. Even when it's not easy to do, I think I'll be able to tell you what direction to head in and where to get started. So with that said, let's dive into the first topic. First category, old PostScript fonts, also known as Type 1 fonts. Obviously, it's implied by the name Type 1. There are other types, Type 3, Type 42, there's a lot. If anyone doesn't recognize this font example, this is Computer Modern, the classic tech font. And this was the standard for many, many years, for especially like high quality raster typography. But it's been scheduled for demolition for quite a long time at the application level. So Microsoft dropped it from Office and whatnot in 2013. It was around 2017 when open source apps like LibreOffice started to drop it, and that's sort of when they adopted different versions of underlying libraries. But 2023, just a year ago, that was officially the kill date for Adobe. At the technical level, this is the easiest to fix because there's an official successor. OpenType was created specifically to be a superset of this format and of TrueType together, which gives us one real clear plan. We want to take our old Type 1 font and up-convert it. And the main challenge you're going to find when you do that is that there's data missing. And we'll talk about why. But just so we're clear, a lot of people still have these fonts, a lot of them. The canonical example / worst offender here is tech folks. You can use OpenType and TrueType fonts with tech, but the old ones persist and will probably continue to persist pretty much indefinitely. There are commercial non-free tools to do these conversions. This one is $100. Personally, I think we could do better than that. We can do better things with our 100 and convert them cheaply. So first things first, in this process, what is inside the Type 1 font? Well, the actual glyphs are stored as cubic Beziers, which is just the curve type. I think it's worth noting, though, that there is a hard limit on the number of glyphs you can have in one of these, and that's one of the main reasons that application vendors are dropping support, is that's not really enough anymore. 256 means you have to have separate fonts for small caps, and you might not have all the accent marks people need, and that gets annoying. There's also the issue of which glyph corresponds to which conceptual character, just a fancy way of saying this is pre-Unicode stuff. There's also some peculiar things, like sometimes the metrics, like the widths and heights and offsets of the glyphs is external. But the final thing, there's also a big deal, which is there's a fixed number of styles in a family. It's called a RIBI for that acronym: regular, italic, bold, and bold italic. Those are the only 4 styles that you're allowed to have. You can't have thin and regular and bold, for example. So these limitations are why it's getting dropped and has been dropped by others. When it comes to the Beziers, I want to show an example of this just because I'll be talking about it. The cubic Bezier, you can see the points on the curves also are met with some off-curve points. Those are control points. They have little handles and allow you to control the angle and the tangents. Also notice that in this example, this is from Cantorell, which is a cubic Bezier font. There's 3 different contours there, and they overlap each other. That's fine. The reason is it's going to get filled in. So like the interior of that curve, because it's a closed curve, just gets filled in when it's rasterized. In contrast, this is an example of the same character in a quadratic Bezier. I think this is Source Sans. You'll see, if you look at those control points, that every pair of on-curve points is sort of joined with a little armature. So you look at the sort of the shoulder of the A right above the enclosed part there. It's different math, right? And that means they're not interchangeable. That's why they have historically been in different tables and things. And there aren't any overlaps here, but do notice that there is an interior curve and an exterior curve. And the green fill on the E is just an artifact of the program. Here also, like, it's going to get filled, so like the interior curve needs to not be filled, and the way that it does that is by having a different winding direction. So it's the counterclockwise on the outside, clockwise on the inside. Not a lot of choices there, but that's how the rasterizer knows. It's a closed shape. You fill this part, you leave this part open. And that turns out to be important when you're talking about single stroke vector fonts, as we'll get to in a second. Back to the font contents. That's quite a bit of stuff. It's not everything. If we look at the periodic table, what we need to build a usable font, I've sort of highlighted in red what there is, I think, in the Type 1. And, you know, that third column, we can use CFF and CFF2 for our glyph shapes. That's what that is designed to do, so that's not controversial. They're a little different. CFF2 is just newer. The top left item there is the character map table. And if we know what the encoding is, because it wasn't Unicode, we should be able to fill that in, and we can probably do that. And the metrics are those other left-hand column red blocks. The green arrows are things we may have partial info to, or can calculate. Some of the metrics you can just sort of compute. And in a lot of ways, this is scriptable stuff. Like, if you wanted to, you could write a script to do this with font tools, the Python library, and so on. But you kind of don't need to do that because, again, this is an official successor we're dealing with here, and Adobe has an official utility called makeOTF that does exactly this. It's part of their bigger AFDKO, which is the Adobe Font Development Kit for OpenType. It's Apache licensed. You can go grab it from GitHub right now. I think maybe people just aren't super aware of this. The bottom of this slide gives you an example of what the format of a command is. It's makeOTF. You have an input font, which is probably PFA or PFB. Those are the same. Those other switches tell you or give you some important options. R means release mode, otherwise it puts demo into the name of the font. GF tells it to use this like glyph order encoding database file. And then B and I are optional when you need to indicate this is the bold version or the italic version or the bold italic version. The inputs you need is maybe worth discussing though. So you have to actually have the font. You then need the font menu name DB file, which is a text file that just has the name that you want to appear as is shown to applications. And then there's this glyph order and alias DB, which is our encoding. We might know that, we might not. There's an Adobe standard encoding that most fonts of this format are going to be, so maybe we get by with that. And then that features file there, there we go. Sorry, I was losing slides. That features file there is where you would put OpenType feature things like ligatures and substitutions. In one of these like older type 1 fonts, you're probably not actually going to have that information to use. You may have some kerning information that you could put into a features file. It's just not a given. I didn't find anything that will automatically convert stuff like kerning information from an AFM file into a features file. That'd be a good project for someone to take on. But the main challenges, as it says on this slide, are the encoding. There's a few of those. There's a good list at the archive team's site there. It's probably going to be Adobe standard encoding, which means it can be handled by the script. If you want to look at examples of how to use the font menu name DB tool, there's a really good repository on GitHub, which I've linked to there, which has font menu name DB for a whole bunch of like widely known type 1 fonts that you're going to find. Now there's an alternative to this, like that might seem pretty simple. You just run this command and you get a font at the end of it. But you're kind of at the mercy of that restricted set of ancillary files you'd have to have. What if you don't have those and you want to like manually edit these things? Well, FontForge can do this. I mean, the type 1 format is old enough to be usable. It's well understood. You get the FontForge GUI. There's just sharp edges to doing that. So it's worth it, I think, if you aren't able to use makeOTF the way you want, but just be aware that you're digging into FontForge, which is it's old and rickety at this point. It's served well, but it's not super friendly to use. So that's kind of all I think there is to say about type 1 conversions. We can move on to the more fun stuff now, which includes bitmap fonts. As I was saying, this is mainly for aesthetic and creative uses. So like, we just want this to look good. We're going to be using these fonts probably in something like GIMP or Inkscape, not to write actual school reports or office memos in, which is helpful to us. The challenges mainly are that there's a lot of different formats, because this is the format that fonts were distributed in for decades. And they tend to have very little in the way of metadata. Sometimes that's not important. It's like the name of the font, okay, we can still find it without the name of the font. But also things like how are the pixels square or rectangular, you might not have that information. I have identified 2 options to look at. One is to repackage the font as is into OpenType, which is doable, surprisingly. And the other is to sort of upconvert it into like a more modern format. Like I said, there's a catch-all here. Bitmap fonts can be a variety of different things. X fonts or PCF. Mac and Windows have their own formats. The Linux console, for some reason, slightly different format, PSF. BDF is probably the one that you're most often going to run into. That was created by Adobe, and I think the issue there is that BDF was designed to be cross-platform and travel with applications. So it's just an easier way to distribute something where you don't know which system it's going to end up on. If you look inside a BDF font, it's text, it's readable. You don't have a lot. There's a few properties I'm leaving out here that are optional, but you have the name, you have the point size it's meant for, resolution. That font bounding box is the bounding box for the biggest things in the entire font, so it's font wide. And then you have a list of glyphs. It says how many there are there with the in glyphs key, but each of those glyphs has its own little stanza to itself. There's a start char and an end char bookend for that. It tells you what the letter is, and then the encoding, again, probably Adobe standard encoding. Overall width in bounding box that has a few other pieces like the offsets. You can see the X offset and Y offset there kind of give you where the baseline is for things that need to overhang the baseline or swoop back to before the origin. And then the actual bits, they might be in the format you choose, they might be ones and zeros. It's more common to encode that a little more compactly. BDF puts them into hex, so you see that first line there is 2 hex letters, hexamals, I don't know, 70 anyway. So that's what the format is. Glance back at the periodic table now, and you see we don't have a lot of information here, right? We've got a little bit of information about the character map, maybe. We have a little bit of the metrics, which are those, again, the left-hand column things. And then the question mark on the 4th column there is what we can do with the bitmaps themselves, because that EBDT table is designed for black and white raster images. If we were to open up a BDF font in FontForge, which you can do, you will see the actual bits. There's a grid editor there on the right. You can see the letters on the left, and you see that the editing window that you get there has very few tools. There's a pencil and a zoom tool and a hand tool, and that's basically because you turn each bit on or off, and that's all you have. The option that we have of putting those bitmaps into the EBDT table kind of gives us an OpenType wrapper. This was officially picked up by the X folks years ago and given a new name, OTB, which is not officially part of the standard, but is widely supported and still works in HarfBuzz and in FreeType and all the libraries on free systems today. So if you just take bitmap font, move those into an EBDT table, call it OpenType on the outside, it should work. And as I dug around, I found 2 fairly reliable tools that do this. And I'll talk about them each in turn. The first one here is font to SNFT. Again, I said SNFT was the name of the overall structure of those tables and things. This is part of the Xfont utilities package, so it may be installable directly from your distro's repo. What this does is convert the bitmap to a bitmap in the EBDT table. The second option here does something else, which is worth looking at. That's bitmap font to OTB. It gives you that bitmap to bitmap conversion in the new table, but it also traces all of those bits and gives you a vector version that looks like pixels. I have added a caveat there, which is fairly important, which is that that's a Python tool that needs FontForge's Python bindings, and those are not installable through PyPy or pip or any of those tools, so you have to get that separately. Just be aware of that. Let's take a look at the font to SFNT option. By default, this puts everything into Unicode encoding. So it expects there's an Adobe standard encoding there. There are some switches to disable that if you know you have a different option. And again, as I said, it's putting the original bitmaps into those raster glyph slots in an EBDT table. It also creates an empty or nearly empty glyph table, which is the Apple TrueType format. Which is just sort of there to keep things from erroring out when it doesn't see the tables it expects. Be aware that it's BDF only, but that's not a huge issue because all of those other bitmap formats, there's generally a tool to jump back and forth between them. So I ran this on the fonts, all the fonts I could find in the X11 family, and worked fairly well, I thought. This is what you get as a result. This is from Lucida Bright. That's a very famous old Bigelow and Holmes font from back in the day. And you can see that it has been converted. It is, if you look at the grayed out text there, it's in .otb font, but it is still the bitmaps, and they're just stored in this new table. And so we still have on the right-hand side there that bitmap font editor. Let's look for comparison at the other option, bitmap font to OTB. Like I said, this also does that trick about putting the glyphs into a EBDT table, but it also traces them as sort of vector contours that are rectangles drawn around the pixels, and it puts those into CFF format, which is the cubic Bezier format. It does officially accept PCF fonts as well as BDF, but again, it's not a huge deal to convert bitmap to bitmap. There's a ton of tools for that. This is what you get from this conversion. You can see there on the left, we've got all the glyphs there appearing, but if you look at the right, the panel that we opened up there to edit the glyph, you see a lot more tools. That's because that is a vector representation of the original pixels as little rectangles. So this is kind of fun, right? Like, this is something that you can just pull into any application and use it because it has the vectors. So you can use that in GIMP or Inkscape to do some creative work, but it's also a good option if you're wanting to make your documentation for how to use your character display. It'll work in any application, and it looks right, so that's what you want. I think that's all I had to say about bitmaps for now. I'm going to try and leave time for questions, so we'll see how that goes. And I want to move on to the third use case, which is stroke fonts, single stroke path fonts. There's a few different names that you hear from this. You hear for this. You might be familiar with the Hershey fonts. This is a real famous project from the 1960s, 1967, I think. Dr. Alan Hershey at the U.S. Navy made this massive set of fonts. There's single line, there's double line ones. They are math symbols in Greek and Cyrillic and Japanese kana, and they're also all straight line segments. So I think this was done for vector displays that drew directly onto, phosphor. It's well known. It's kind of just one set of fonts though, and those are public domain, so they've taken on a life of their own. When we look at the problem of how to use stroke-based single stroke path fonts, maybe the key takeaway there is that they're not used in desktop applications. Like, this is something that's needed for CNC routing and laser cutting, and generally that means that a font that isn't going to cooperate with your font manager and with LibreOffice might still be fine because the 3D CAD software or whatever is expecting a font that behaves in a different way. I also would want to note that there's a lot of contemporary examples of this. I was surprised at how many there were when I dug into it. People make these even today. This is the project from 2024 called Routed Gothic, and yeah, I was surprised, but yeah, there's a link to that at the end, so you can go check it out. But if we look at the problem of how to use these today, because people are still making them, for the most part, you don't have the missing metadata, the missing metrics data issue. But weirdly, this is the hardest thing to convert into OpenType, at least if we're following the rules. And that's because of what the contents of the actual glyphs is. And I brought this up earlier with like the cubic Beziers and the quadratic Beziers in contemporary fonts, but those are closed paths, and that matters. That's how the rasterizer, free type, whatever, knows what to fill and what not to fill. And you don't have that in a single stroke path font. It's an open contour. It has a beginning point and an end point because a tool is tracing it out, but it's tracing it once. And it's zero width in a sense, but the cutting of the tool is giving it some width. And turns out that's different enough that it requires some thinking. But I did want to point out that notion of TrueType and OpenType fonts having closed contours is only true for those first 3 tables of where glyphs can go. And I think that's kind of the key to doing something interesting. Like, if we have an open contour, it won't fit in CFF or glyph, but there's that SVG table. Single open contours are fine in SVG documents, right? And this was my first thought. was I still think that it's the right way to do this is to take those open contours and put them into an SVG table. SVG supports, cubic, quadratic, whatever you got, and it doesn't have to be a closed path. There aren't a lot of SVG in OpenType fonts these days. It got into the standard with the other emoji and color font formats because Mozilla and Adobe were using it, but it's always kind of a burden to implement because it's a separate standard. You have to have an SVG renderer. So great if your laser cutting software is using SVG, but it's probably not going to be supported in LibreOffice because then they have to hook SVG support into another place. And eventually the other emoji and color font formats sort of caught up to what SVG could do, so it's not as widely done anymore. So the two options there I see are, again, take those single contours, put them into an SVG table, or maybe we just make a non-compliant font. We just leave the contours open, put it into glyph or CFF tables, and see what breaks. The best example I've found of the SVG and OpenType format for a non-emoji font is this called Release Single Line, which is open source. This is a screenshot of the homepage there. It's pretty massive. It has a lot of modern features like ligature and kerning and stuff like that. Wide variety of output formats. There are regular OpenType, TrueType version of this in addition to the single stroke version designed for cutting, as you can see there. The problem is that it was designed in Robofont, which is a proprietary application that it's not going to run on Linux. So even though they released the script for how they made it, it's not usable. It hooks into some Robofont specific libraries and extensions. Ironically, there is another tool designed for making OpenType SVG fonts for Microsoft, and it's also open source, but you can't compile it on a Linux system. So I don't know that there's that much in that you would actually want to pull out and make a GTK version of, but it would be an interesting exercise. At least the code is open in both of those cases, though. The other angle is to just look at the non-proprietary tools that exist in FOSS, and I've found two of those, one from Adobe, one from Mozilla. No surprise, this was their standard proposal. Both of them work the same way, which is they expect you to put together a massive directory of one SVG file per glyph and just have however many of those you need, dozens, hundreds, named for the glyphs, and then you run this script that looks through the directory you're in, pulls the SVG files out, packs them into the SVG table inside the OpenType font. I found that really fragile. I couldn't really get a good example of it working entirely. That may change. I feel like it's probably not going to, but I hit on another idea while thinking about that, which is you can make what is called an SVG font, not to be confused with SVG and OpenType, and that is the font in SVG format that would be inside an SVG document. So it has to have letters in there somehow. It's kind of the same idea, but without all the OpenType wrappers. And as it turns out, you can do that with FontForge in a single line. The trick is that even Inkscape doesn't actually let you set text in that. If it sees an SVG file that has an SVG font in it with text in the SVG, you can see it, but you can't use it as a selectable font when you're creating new work. So what's the alternative? If the SVG thing isn't super convenient, well, what if we just stopped caring and just left open contours in the font, in the glyphs? Obviously, there's not a lot of work involved there. And again, your routing and vinyl cutting tools know what they're doing, so you just have to be careful to not install that font system-wide and then expect it to work everywhere. Maybe we just do that, right? And as it turns out, that is what the CNC and laser cutting people have been doing. So you can go out and find a lot of single stroke fonts that are in TrueType or OpenType format and just don't obey the rules. This is an example of one, let's see, can't remember what the name of that one was. Cambam. It's a set released for free by someone just personally. If you look on the left in FontForge, you see empty slots for the glyphs, or you see these weird black bubbles. That's because FontForge can't rasterize that because it is a vector contour, but it is in a closed shape. You see what it looks like there on the right. You can see that you have your vector editing tools, but man, slides are not cooperating. Okay, but it isn't a filled shape, so it's not going to work right as far as font forge is concerned. It's not going to look right in your font manager, but it does work on the vinyl cutter and the laser cutter. There are scores of examples like that out there to be found. There's also, actually, the second resource there is probably the better one for that. This is a blog post from 2015 with a lot of resources for these fonts that are single stroke, specification breaking fonts, let's say. There's also this extension for Inkscape that was, I think, put out by Mad Scientist Labs, and it lets you use those original 1967 Hershey fonts in Inkscape, but again, it turns them into a vector drawing rather than converting them into a font. So it's not exactly the same thing, but since this is such a specialized application, maybe that's good enough. Honestly, I would like to see somebody port this SVG in OpenType RoboFont script to some other build system, some other font editor. That should be doable, but I think it's probably too complicated. You could just do a simple script. Like the RoboFont thing is for people working in RoboFont. So if you did that in another font editor, you're sort of building into the editing environment. You could just make a script that takes a TTF font with an open contour in each glyph, pulls out those one at a time, puts them into an SVG table. I haven't had time to tackle that. It's the kind of thing that interests me, so I may do that. If you're interested in this topic, definitely get in touch. And then the last thing there is I wish there was some like better actively curated font collection for this sort of thing, because if you search for this, all you find are like people asking on forums and other people responding with links, and those links go dead fairly quickly, and it's not the best way to store information. Forum pages die, and CMS churn happens. Last thing I want to mention, I think that's the endpoint for SVG single stroke path font options. The last thing I want to talk about, because I did mention this, I think in my abstract, is what you do with those character displays, the little hardware devices. As it turns out, and this is not a surprise if you think about it, converting from a modern OpenType font to a PDF or a BDF or PCF bitmap font is really simple. That's because all you're really doing is rendering it. So there is software out there to do this, but it's not really complicated enough. I think if you find yourself with the character display and it doesn't have a font you like, you can use any font that you want that's a modern font and do that conversion. The trick is that loading it into the ROM of the character display is very device specific, and you have to follow the rules and the techniques like set up by the manufacturer. Maybe another thing on that character display point is, do we really care? Like, all right, so this is the low end of devices and displays, right? Lowest resolution possible. Will that always matter? Isn't that going to get higher resolution? I would say yes, but there's always going to be some low end. Just look at like virtual reality goggles right now. The resolution of those a lot worse than big displays and printing. So even if it gets better, something else will come along that's a lower resolution, like projecting it onto your glasses. So there's always going to be a low end to care about, and bitmaps may be what you need for that. That's all for me. This is a list of the screenshots. You will read that in the slides, I think. Same is true for your type 1 links, bitmap links, single stroke path links. Look at those later. I think we should have time for questions at the end of this. Thanks for your attention. These are the fonts in the talk, and I hope to join you live in a little bit. Thanks.